Machines do not get more extreme than this. We are looking at steel structures that weigh more than entire neighborhoods, dig holes the size of football fields, and move so slowly they need 3 weeks to travel 14 miles. These are not props from a science fiction movie, but real equipment operating right now. The engineering behind them will challenge your sense of scale. As outlined in the original script, we are examining 12 machines, each one more impressive than the last. By the time we reach number 12, the sheer ambition behind these builds becomes clear. This is not just heavy equipment, but what happens when human beings refuse to accept that something is too large to build. If giant engineering interests you, subscribe right now. There is a lot more content like this on the way. The largest land vehicle ever built rolled out of a German factory in 1995. It is called Bagger 293, a bucket wheel excavator used to mine coal, and it operates on a scale that is difficult to grasp until you see it. It stands 315 feet tall and stretches 738 feet long, with a weight of over 31 million pounds, a figure officially recognized by Guinness World Records. That is heavier than 8,000 cars combined. It moves at a crawl so slow that driving it 14 miles to its first job site took 3 full weeks. But once it arrives, nothing on land matches its capability. Every single day, Bagger 293 scoops out 8.5 million cubic feet of dirt and rock. That is an entire football field worth of ground, dug 80 feet deep, removed in 24 hours. A rotating wheel covered in huge buckets never stops spinning. Germany built this machine to rip coal straight out of the earth, and it performs that job relentlessly. Underground, a different kind of machine was eating through rock. Big Bertha, the largest tunnel boring machine in the world, was built in Japan and assembled in Seattle in June 2013 for the SR-99 tunnel project. Its job was to drill a highway tunnel under one of the biggest cities in America. It measured 5 stories tall and 300 feet long, with a weight of nearly 7,000 tons. That number sounds abstract until you picture a machine so enormous it takes a full construction crew just to manage the pieces when it moves. The way it works is almost biological, with a giant rotating face covered in cutting teeth that grinds through rock and soil, while the machine behind it lines the tunnel walls automatically. It excavates the earth and builds the road at the same time. Big Bertha was not just a machine, but a moving factory, hiding underground, doing work that no crew of humans could ever replicate by hand. As detailed by WSDOT, it turned a highly complex Seattle project into a real highway. The Eiffel Tower stands 330 meters tall, which is an iconic measurement. Now picture that same length, lying flat, rolling across a mine on wheels. That is the overburden conveyor bridge F60, which is over 1,600 feet long or 502 meters from end to end. It moves along tracks like a very unusual train, though not quickly. Its entire purpose is to carry dirt and rock across open mines so other machines can get to the valuable material underneath. Even with some attachments stripped away, it still weighs 11,000 tons. People call it the horizontal Eiffel Tower, and that nickname makes sense given its dimensions. The real Eiffel Tower is a monument to human ambition, and this machine is too, except this one has a job to do every single day, grinding across German mining land and moving material that no other machine could shift at that volume. It is both highly practical and brilliantly designed. Strength has a record holder, and it sits at a shipyard in China. The Taisun gantry crane holds the Guinness World Record for lifting the heaviest load ever recorded, with its heaviest single lift topping 20,000 metric tons. To visualize 20,000 metric tons, you would need to line up thousands of elephants. Built specifically to put enormous components onto ships, The Taisun is the reason those vessels can even be assembled. You cannot bolt a 20,000-ton piece onto a ship with regular equipment, so they built the strongest machine humans have ever constructed for exactly that purpose. Every time a new ship rolls out of that Chinese yard, this crane had a hand in it. Nobody builds things at seagoing scale without something like this behind them. And without the Taisun, entire categories of modern shipbuilding simply would not exist. Most people picture a bulldozer as a medium-sized yellow machine they see at construction sites. But you should forget that image entirely. The Komatsu D575A Super Dozer from Japan is 38 feet 5 inches long and 16 feet tall, with an operating weight of 336,400 pounds. The front blade alone stretches over 24 feet wide, making it wider than most houses. It does not push light soil around suburban lots, but tackles the toughest, earth-moving jobs on the planet. It handles rocky terrain and dense material where anything smaller would stall out or break apart. The engineering inside it is matched to every inch of its size, featuring an engine powerful enough to keep that 336,400-pound frame moving through ground that would stop lesser machines cold. Japan built this for extreme environments where production cannot slow down. One push of this blade moves more material than a fleet of standard dozers combined, making it an absolute powerhouse. From far away, it looks like a factory, but standing next to it can be disorienting. The Komatsu P&H 4800 XPC is the largest electric rope shovel ever manufactured. From arm tip to base, it towers approximately 46 feet tall and stretches 49 feet wide. It runs entirely on electricity, using vast amounts of power to scoop rock and ore with an arm the size of a building. The scale of this machine warps your sense of what a tool is supposed to be. Yet, we call this a shovel. The version you use in your garden weighs a few pounds, while this version weighs more than most ships. It works in mining operations, where the volume of material moved each day makes standard equipment look tiny. Built to outlast entire mine life cycles, the 4800 XPC does not take breaks and simply keeps digging. If you are enjoying this list of giant machines, drop a like. It genuinely helps more people find videos like this one. Standard commercial dump trucks haul maybe 20 tons if they are built tough, but the Kress coal hauler easily surpasses that number. At over 60 feet long and roughly 18.5 feet tall, this machine was designed for one purpose only, which is moving coal out of mines faster than anything else could manage. The empty weight alone sits at up to 185,000 pounds before a single piece of coal touches the bed. Once loaded, the number climbs into territory that normal road infrastructure simply cannot handle, which is why these machines live exclusively on private mine roads and never touch public ground. They exist in a world built entirely around their dimensions. Mine operators do not choose a machine like this because they want something visually striking. They choose it because the alternative is running dozens of regular trucks on the same route, burning more fuel, requiring more drivers, and moving less material. This one truck eliminates all of those inefficiencies at once. Most machines on this list were born in the age of computers, but Big Brutus was built in 1962 and still belongs here. This American electric shovel weighed over 5,000 tons and packed up to 15,000 peak horsepower at a time when the world had never seen anything like it. Its bucket was large enough to hold an entire living room or 3 railroad cars inside the scoop. Big Brutus worked the coal mines of Kansas for 11 years before electricity costs and new environmental standards made running it too expensive, meaning even this giant had an economic ceiling. It retired in 1974 and became a museum piece in West Mineral, Kansas, where it still stands today. What makes it different from a typical museum exhibit is that the machine itself is the museum. You can walk inside it, go up through its structure, and realize what engineers accomplished with 1960s technology. They used raw steel and ambition without any computers or modern materials. The Netherlands built something different. Where most giant machines burn diesel by the barrel, the Mammoet SK6000 is capable of running entirely on electricity, making it the highest capacity electric crane in the world. Its maximum lifting height is nearly 900 feet straight up, which is higher than most skyscrapers. The SK6000 was designed for large modular construction, focusing heavily on the assembly of next-generation wind turbines, which means a major part of its purpose is to build clean energy infrastructure. Giant machines building green machines is a fitting combination. The engineering required to lift wind turbine components, which can weigh hundreds of tons, to heights of over 700 feet without a single diesel engine running, is notable. Most cranes that size run on fuel-heavy systems, but the SK6000 proved those systems were unnecessary. Built to work offshore and onshore at wind farms worldwide, this crane represents a clear sign that heavy industry is moving toward cleaner power. Before diesel took over and electric rails became standard, steam was the only way to haul serious weight across mountains. Nobody did steam quite like the Union Pacific Big Boy. Built in the 1940s, this American locomotive measured 132 feet long and weighed 1.2 million pounds. Pulling freight trains over the steep grades of the Rocky Mountains was its entire reason to exist, and it did that job at a scale no other steam engine in history ever matched. 25 were built in total, and 8 survive today, with one of them still operational at special events. Seeing a big boy in motion is a powerful experience, characterized by the sheer volume of steam, the noise, and the ground vibration. Nothing modern replicates that exact feeling. The diesel age ended the big boy's working life, but the engineering inside it remains a ceiling that steam power never broke through again, and that record still stands. A machine that flies is rarely built to this scale. The Antonov AN-225 Mriya was constructed by the Soviet Union to carry spacecraft on its back rather than inside, and it performed exactly that function. At 84 meters long, with a wingspan of over 88 meters, the AN-225 had a maximum takeoff weight of 640 tons and could haul up to 250 tons of cargo through the sky. It carried industrial equipment too heavy for any other aircraft, transported entire power plant generators, and once carried the Buran space shuttle on an open-air flight. Only one aircraft was ever completed. It was destroyed in February 2022 during the war in Ukraine at an airport outside Kyiv. A second airframe was under construction for decades but never finished. The AN-225 represented a distinct category of aviation, making physically extreme transports look routine, and no direct replacement currently exists. Every machine on this list digs, lifts, drills, or flies, but this one does something completely different. The Large Hadron Collider, built underground on the border between Switzerland and France, is officially the largest machine humans have ever constructed. It is a ring-shaped tunnel, stretching 17 miles around, that was switched on in 2008. It does not move dirt, but rather moves subatomic particles, accelerating them to near the speed of light and colliding them billions of times per second, so scientists can study what the universe is made of at the smallest possible scale. Every other machine on this list exists to build something or move something, while the Large Hadron Collider exists to expand our understanding of physics. It is the biggest tool ever made, built for the smallest things imaginable. That contrast is exactly why it earns the top spot. Bagger 293 moves mountains, but the Collider asks why matter exists at all. That project, built by thousands of scientists across dozens of countries, is a deeply ambitious scientific endeavor. From a German excavator that weighs 31 million pounds to a 17-mile underground ring chasing the secrets of particle physics, these 12 machines share one common trait. Humans refuse to accept the limit or say it is too heavy, too far underground, or too high in the sky. Every single one of these structures was built because someone looked at a difficult problem and decided a larger machine was the answer. Let me know which one stood out to you in the comments below. If this kind of engineering interests you, subscribe to the channel, as there are many more videos like this available.